are here. We are in the machine learning one. So I think you guys have some basic understandings of mathematics and statistics. You have taken econometrics course. The next step is this one, machine learning. And then this is going to open up a new, completely new world in front of you, what you can do with data. Because I can say, literally out there, there is only 20% of data out there that you can exploit using econometrics. 80% of the data out there, you cannot use econometrics. We're going to talk about the reasons why that's the case. But I want you to understand the importance of machine learning. So why you should learn it. Your generation, I think, in my opinion, it's a must for you guys. Then the next steps are deep learning and AI, of course. So I'm putting together a course for deep learning. It's called Deep Forecasting. It's going to be offered next fall, I believe, if not spring, but next fall. If you're around, I would be more than happy to see you guys if you like this course. If not, I will make a GitHub repository and make it publicly available. So wherever you are, feel free to clone to my GitHub repository. Okay, so let me give you a little big picture. We're going to talk about machine learning in a lot more details next class, which is the introduction to machine learning. What is machine? So this is introduction. The next one is what is machine learning. But today, I want to make sure that when you're leaving the class, you understand what is the difference between econometrics and machine learning and why you should learn machine learning. Okay. So what are we doing? What are we trying to do as a researcher in general? Okay. What do you think? What do you want to do? I give you some data. What do you want to do with that data? What's your goal? Any thoughts? Well, we can see the answer as well, right? You want to solve some real world problems, right? So that's basically our goal, right? Give me a data, and then I can, I don't know, play around with that data, and I can infer some information from the data and come up with some relationship between variables. X and Y, this is a relationship between the two. Then the question that you should ask from yourself is that, is there a theory for that belief of yours, right? So for example, you believe that there should be a relationship between minimum wage and maybe unemployment, right? There should be a relationship between, I don't know, people's eye color and their wage. Again, no right or wrong. You think sometimes you just want to explore an idea. You want to explore if the youngest kid in the family is the spoilest one. Something as stupid as that, right? You just want to explore things. Your next step is to ask the question, is there a theory for that idea of mine? If there is a theory, then you can take it from there. If there is no theory, you have to work with the data and start from there. Does that make sense? Okay. Sometimes for our questions, there's a beautiful theory like this. Is there a relationship between quantity demanded and price, and income, technology, price of competitors, and substitute? Yeah, Econ 101, this is law of demand, right? If price increase, the quantity demanded decrease. If income of the family increase, the entire demand will shift up. Things like that. So there is a theory for that, right? However, there are lots of other interesting questions out there. In my opinion, plus 90% of the interesting questions out there, no theory for them, right? So for example, what is the relationship between sales and advertisement? What's the relationship between sales and R&D expenditure? Sales and seasonality, industry, right? There's no theory, but it's $1 million questions, right? For companies like, I don't know, Amazon, Netflix, all the retail companies, the sale, it's a big deal. So should you give up because there's no theory? The answer is absolutely not. So you have data. We are going to use some econometrics or machine learning techniques to extract information from that data, right? And some questions like this one: wage, education, age, gender, experience. If you have taken my econometrics course, you're sick of this relationship, right? Wage, education, age. So bear with me for 2 more weeks, and then we're going to be done with this wage, education, and age. So let's actually start with a very simple example. So this is a very simple example. What is the question that I have in mind? I want to see if I can predict your salary, right? Well, we have 30 students in the class. We want to see if you can predict their salary, right? So start with this. Is there a theory for it? What's your answer? No. There's no theory connecting your salary, your wage, with some underlying factors. What are the underlying factors? Education, age, experience, IQ, ethnicity, race, gender, let's say industry, location, working hours, talents, you name it, right? These are the underlying factors, and there's absolutely no theory out there for them, right? However, with econometrics, let's start with econometrics now, right? I want to solve this problem using econometrics. We can build up a model. Let's assume that we are going to make assumption. As economists, we always make assumption. Do you remember the joke about the economists, chemists, and physicists? So we don't have time. I'll tell that joke later on to you guys, but it's a funny one. As economists, we can always assume things, right? We live in a world with lots of assumptions. So let's assume that there's a linear relationship between education, age, experience, IQ, and you name it, and wage, right? We write down a linear functional form like this, and then we throw data at it. We estimate the numbers, estimate the coefficients, beta 1, beta 2, and etc. Then we have a model in our hands using the data. Now let's answer these questions. Can you interpret this model? Do you care about interpretability? What's your answer? If I tell you that this coefficient is 0.5, can you interpret this model? The answer is yes, right? If education increased by 1 year, your hourly wage is going to increase by 50 cents. Is everybody on board? Does that make sense? Okay, so we can interpret that. Do you care about the interpretability? This is something that I want to spend some time. Do you care? This is really important. This is the main difference between econometrics and machine learning. Do you care about interpretability? It's not a difficult question, and I want you to just participate. Say whatever it is. It's going to be either right or wrong, right? Who cares?
I think it depends.
Okay, so why it depends?
I mean, if the model works, I don't really care if I can interpret it. Like if it has predicted, if it can predict the future, I don't really care if I can interpret it. It can do what I tell it to do.
Yeah, you should go to Wall Street. You do care, right? You're a policymaker. No, I'm kidding. Yeah, it depends. Yeah, of course, it was a fair answer. It may depend, but as a policymaker, you care a lot to figure out this number, right? Because then you can spend more money for education, and then you can increase people's wage. It will increase maybe welfare for the society and things like that, less crime and things like that, right? So we definitely care about interpretability. Okay. And can you make prediction using this model? The answer is yes. Again, given the fact that we have a model with those assumptions, and if those assumptions are not violated, the classical econometrics assumption, then I can make prediction, right? Imagine I have a model and I come to this class. I ask you, Ryan, what is your education? I know it. What is your age, experience, IQ, and etc. I say like, okay, Ryan, when you graduate, this is going to be your wage, plus minus some confidence intervals, right? So we can make predictions, right? Okay, then we're going to say that the last one. Can you make this functional form more flexible? What are the caveats? So what do I mean by making this functional form flexible? Right now it's linear. Everything's linear. You can bend over this line as much as possible, as much as you want, right? But the problem with that is, so for example, why may I be interested in putting education to the power of 2 to this model? Because I believe that if education increase, the wage is going to increase at an increasing rate, right? So you might say that, okay, why not going to the degree of 3? Why not to go to the polynomial degree of 4? Why not 5? Because maybe it's going to do a better fit to the model. And the answer is yes, it will. But why should I stop there? Because if I go to the degree of 5, I cannot interpret that. When I take derivative, the derivative is going to the power of 4, shows up to the model, and then I can literally not interpret that. So I lose the interpretability. But going back to the first question, do you care about interpretability? Yes. So that's why in econometrics, we're going to work with simple models, simple linear models. We're not going to make that model as flexible as possible because we do care. If I make my model flexible, I will lose interpretability. And this is something that I care a lot in econometrics. Now let's look at another example. Imagine you want to classify cats versus dogs. So this is a classical cat versus dog classification problem, image recognition. Take a look at this one. This is your data. Where do you start? Is there a theory? No. Can you do something like this? Why do you think you cannot do something like this? What's the deal with this data set that you cannot think of a model like this? What do you think? What do you think? Yep.
You're using more like
qualitative features than quantitative. It's kind of like looking at pictures and it's like more words than numbers.
So you're saying that the data structure is different, right? So, well, we're going to talk about qualitative, quantitative. So it's not necessarily the correct word, but it's exactly the correct point. Yes. So the structure of the data is different. What else?
Well, I was just going to say that for each person, you can identify their age, their education level, their things like that. But for image recognition, each image is comprised of a completely unique pixel set. And so it's impossible to predict what overlapping features you're going to have in each pixel set.
Yeah, exactly. Well, this goes exactly alongside what he was saying. So the data structure is different, and we're going to say that it's not impossible. It's actually there are ways to do that, but exactly you guys are exactly on the right points, right? So the type of a data here, it's different. I cannot put it in a nice row and in a table with rows and columns, right? We call this kind of data set unstructured data. And the data that you can put it in a nice table, you can summarize it in a nice table, you call it structured data. Econometrics model can only handle structured data sets. So anything that comes to unstructured data, it's impossible with econometrics. Why? Because, and what are the examples of unstructured data? Voice, images, text, let's say documents, things like that, tweets. All these things, all these exciting, interesting things are not possible using econometrics. Because those are using unstructured data. And as I said earlier, more than 80% of the data out there is unstructured or semi-structured. So semi-structured is a combination of the two. So for example, it has features from structured and unstructured. Look at the pictures on your iPhone. The location, the hours is the structured part, but the pictures themselves are the unstructured part. So this is an example of semi-structure. Look at your emails. The topic, well, maybe the subject, the time, the server is the structured part, but the body of the email is unstructured part, right? So whenever the data is not structured, you cannot use econometrics. Now, can you see that what machine learning can provide? Tons of new things. So literally in finance, you're not able to use, it's not, do you prefer econometrics versus machine learning? You cannot do things with econometrics because your hands are tied. So that's why we're focusing on a distinction between the two. Now answer this question. Do you really care about interpretability of the model? Now you can say, I don't care. Just give me a model. At the end of the day, that model tell me if it is a cat or dog. You cared how I got there. You want to interpret anything? No. Hedge fund manager Ryan, he was working on a Wall Street company, and he just want to make money. You care what's the effect of interest rate on something? He just, again, I'm kidding, but there are literally some hedge funds out there that they don't care about interpretability. They just want to say that give me a signal that I can win 51 over 49. As long as it's like a casino, right? 51, 49, I just use law of large numbers, I become a millionaire. Okay, so this is a very important slide, and we are going to repeat this slide many times during the semester, but let me give you a high-level preview. So on the left, we have a statistical learning. On the right, we have machine learning. Let me call this SL, ML, right? Because I have to say a lot, right? So the focus on SL is hypothesis testing, interpretability. You guys are all familiar with hypothesis testing. You have a belief, you want to test it, use data, use econometrics, and then based on some assumptions, say that if that statement is valid or not, right? In machine learning, it's all about predictive accuracy. All you care is that your model is accurate or not. In SL, the driver is math, theory, hypothesis. In machine learning, it's only fitting data. I don't care if there's a theory or not. Even if there is, I don't want to use that theory. Okay? I just want to trust the data and see what the data is telling me. That's it. Okay? Again, guys, I'm not trying to sell machine learning to you guys because at the end of the day, you have to use a combination. We're going to talk about it, maybe not this class, but next class, we're going to talk about it, the real world examples. Data size. So machine learning, econometrics, any reasonable size, maybe at most a million record, a couple of million records, or even maybe more. But the machine learning, big data. What is big data? 3 properties, 3 V's, right? Velocity, variety, and volume. So volume, we're talking about billions of records. Velocity, we're talking about real-time data. Econometrics, let's say you work with, at the very granular level, hourly data, right? But machine learning, you're talking about tweets. As I'm talking, it's being transcribed, and the sensitivity analysis is being done until, okay, this professor's tone is positive or negative, and people trade on that. So earning calls, they're making trading signals right during the earning calls. So this is working with real-time data. Does that make sense? Seconds, milliseconds, high-frequency trading. And data type, we talked about it, the structure, unstructured, semi-structured. Guys at home, I know that you don't see the laser. Okay, and sorry about it. And dimensionality, usually econometrics is low dimensional, machine learning high dimensional, because you want to exploit the information as much as possible. Let's make that model super flexible with 200 features, with 300 features. But in econometrics, if I have 300 features, then I will lose the interpretability. Does that make sense? And we're going to talk about the model choice during the semester, for example, what is cross-validation, but this is key, interpretability, high versus low. And strength, so basically we talk about causal relationship, and in machine learning, we only care about prediction. Okay, so let's stop here actually. I'm going to start from this slide next time, and I will basically tell you that, okay, it is as if I'm selling the fact that machine learning is better than econometrics, but it's not. Don't get me wrong. Okay, so I'll tell you that at the end of the day, both of them matters. So you have to look at the application. So in real world, so here's the example that I think many of my students have heard before. So if you're working for a Wall Street company and if you're managing other people's money, right? Let's say I come to you as a manager and I tell you that, okay, our portfolio lost $100 million. I have no idea why. Versus our portfolio lost, let's say, $200 million, but I exactly know why. You may want to go with the first option, but usually when you want to sit in front of a client and explain yourself, you go with the second option. Because even though you lost twice, but you can explain it why. So that's why in real world, in industry, it's a combination of the two. It's a combination of, we use econometrics, and then to make sure that the accuracy of the econometric model is not completely off, we do machine learning. If they're close to each other, your econometric model is doing a good job. If they're far from each other, you're losing some important variables in your econometric model. Does that make sense? Okay, cool. So let's stop here. And the last 1 minute, is there any question from students in the class or at home? Okay, cool. So I want you to please make sure you set up your GitHub account and make sure you can clone my repository. Make a copy of that folder to your local computer. Do not make any changes. I explain myself in the videos, so watch the videos carefully. Okay? And then start working on Python crash course from tonight if you can. Again, collectively, there are 4.5 hours. So I really want you to pin it down before we officially start the class. Okay, cool. All right, so let's pause the recording. Thank you so much, Ryan, for the recording. No, seriously, because.
Thanks, Pedram.
Okay, thank you.